A control plan is a document describing the critical to quality characteristics of a process. Monitoring of system metrics translates into customer requirements. When control is maintained, process variation will remain in check. Control plans are high-level organizational documents of what will be done. The how it is maintained is found in the work instructions at the operator level. All processes and products should have control plans. These serve as excellent roadmaps for employees and the collective organization to ensure objectives, metrics, and customer expectations are aligned. As we deploy control plans, we must ask ourselves which corporate policies should be changed as a result of the project. Have some policies been rendered obsolete? Are new policies needed? Based on the outcomes of these questions, we must be prepared to modify procedures for the new process, modify quality appraisal and audit criteria, update prices and contract bid models, as well as revise budgets and forecasts, change information systems, update the process map, modify training, and seek ways to poka-yoke the system. Let's discuss the elements of a sound control plan. You will notice that many of the themes here are similar to the ideas we have already touched upon. Standardization focuses on what we will be measuring, when we will measure, who will measure, and how we will measure. Steps in the process will be developed through a detailed work instruction to establish and address all these areas of importance. Documentation is essential to ensure that our improved process is entrenched, distributed, and instilled across the organization. As time passes, processes tend to evolve very quickly. Small adjustments in how we perform or work creep in and ultimately become tribal knowledge. Through monitoring, we seek to uncover these pockets of knowledge, and if deemed value added, incorporate into our documentation. Monitoring helps us detect changes and ensure that improvements continue to deliver on expected results. Once we detect an issue, we must be careful to apply the appropriate diagnosis. So often we mistake the source or cause of an issue for something that it is not, and ultimately make the situation worse. Do not knee-jerk or overreact. Carefully adjust and assess to make sure there is full understanding of the issue. Finally, we need a response plan. Response plans document next steps once an issue has been detected and judgment rendered. These plans include actions to be taken within a certain time frame and who will be responsible for execution. There are 3 phases of control plans. A prototype control plan is used in the early stages of the part or process. This level includes more detail on needed materials, measurements, and performance testing. A pre-launch control plan is used during the pilot phase. It is built from the contents of the prototype control plan, but adds more frequent inspections, in-process and final checkpoints, statistical data collection and analysis, and more audits. A production control plan is used once we have reached full production. It is the entirety of the control plan and includes process controls, tests, measurement system analysis, and reaction plans. Since it is based off the elements of its predecessors, this control plan will replace the pre-launch control plan. One useful approach in controlling a process is through dynamic control planning. Dynamic control planning is a collection of essential information that pertains to a process. This information includes SOPs, control plans, FMEAs, gauge control plans, and quality planning sheets. DCPs are living documents that outline a larger scope of documents. As such, when changes are needed, operators have the responsibility to make these changes known so that an update can be made and corresponding training can take place. A gauge control plan focuses specifically on the instruments used to monitor and assess proper function of the process. It is not meant to be a substitute for actual calibration, but more of a guide of what, how, and when certain tasks shall be completed as pertains to the proper function, performance, and upkeep of the instrument. It also outlines contingency planning should certain conditions fail to be met. Procedures are another method we use to ensure control. Procedures define how we do it and help to maintain consistency, accuracy, and quality. As mentioned earlier, control plans are living documents. The flexibility and ability to adjust based on our findings and changing conditions mandate this to be so. Control plans need owners to ensure they are carried out completely and rigorously. Raising the awareness of the team through training helps to ensure that control plans are followed and utilized. We obtain information for our control plan from a number of sources, which include process flow diagrams, FMEAs, design reviews, QFDs, fishbone diagrams, statistical analysis, and historical data or knowledge.